In our previous discussion for Unit 5, Lesson 1, we had completed page 1. If you've not completed problems 4 through 7, take some time to do that for our discussion in our next class. I'm going to begin this video with problem number 8. Problem number 8 actually is a discussion that we started back in Lesson 1, which is the ladybug problem involving the clock. But since we started that discussion to now, we've introduced a lot of new ideas that will allow us to be able to figure out the answers more efficiently. So in this problem here, you're going to calculate the how far the ladybug is above the ground. Again, the clock's still 10 feet. The arm of the hand is still 1 foot. Go ahead and calculate the answers to the times, and as well as estimate the answers for 12:10, 12:20, and 12:40. Turn the video back on when you have come up with your answers. So in our previous discussion, at 12 o'clock, this would be 1 foot above the 10, so hopefully you have an answer of 11 here. At 12:30, you're going to be 1 foot below the 10 feet spot, which is right here. So you're at 9 feet. Again, at 1 o'clock, we're back here at 11 feet. For the 12:35, you can always use Pythagorean theorem. So, because you already know what the coordinate is here. This is a 60-degree angle this way. This would be a 60-degree angle coming down. So, what the answer would be here is the same answer here, except you are subtracting that distance from 10 feet instead of adding it. But going back to what we've been working on, if we go back, think of this as a unit circle, since the radius is given as 1 foot. And if I would divide this up into basically 6, so pi over 6 over 6, that's going to be the top half of the clock, and then these would be 6 pieces down here. So the denominator would be in 6. We could also use the expression we did in the last unit, which should be the height we're starting at the pivot point, which is 10 feet, plus the length of the minute hand times sine, which is the y value of the angle of rotation in radians. So we could also put in pi over 2 for this answer, 3 pi over 2, 8 pi over 2, or 4 pi over 3, and again back to pi over 2. And then for down here, for in this rotation, 12:10 would be here. That would be pi over 6. And then 12:20, if I count around here, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12:20 would be 11 pi over 6. 12:40 would be 7 pi over 6. So you could always put these into this expression that we came up with in the last unit, and you'll be able to get all the answers for both A and B. And with these radian measurements here, you should get the exact answers, at least for 12, 12:30, and 1 of 11 feet and 9 feet. In problem 9, they're asking you to take the information from the previous page, and if you would graph that from a time of 12 to 1. So if you go ahead and do that, when you're ready to continue with that discussion, go ahead and turn the video back on. So what's important here is that you need to understand that we're starting at 11 feet, and then coming down to 9, coming back up to, again, 10 feet would be 12:45 as well as 12:15, and then getting back to 11 feet at 6 o'clock. So this would what the graph would look like. Now keep in mind there are other values that are going to take place in between here. So the best way to show this complete graph of time is to draw a path here. So if you did not draw that path going from 0 to 60, please do that now. All right, so continuing on to the next question. So the ladybug stands in the minute hand, and predict how this distance from the ground will change over the next hour. So from 1 to 2 o'clock instead of 12 to 1, how about 2 to 3? So go ahead and answer that question. There is a mention here about doing this activity with cards, not in groups. So we're going to skip problem 11 and 12. So once you're done with this question here, you turn the video back on for that discussion, and then you'll continue into problem 13. So hopefully you wrote here that from 1 to 2 as well as 2 to 3 that you're going to get the same answer as this answer here, because the function is periodic. In other words, it's going to repeat every 60 minutes. So this is 12 o'clock, but this is also where 1 o'clock will be, which is this point here. This is where 2 o'clock will be, and if I continue to 3 o'clock, this will be the graph for every hour. All right, so in the previous unit we talked about independent and dependent variables, and so if you go ahead and answer these two questions, be very specific about problem 14 in your response, and when you're ready to continue that conversation, turn the video back on. So as we talked about previously, that the independent variable is always the x value in our graph if we're doing an xy coordinate grid, and then the dependent variable would be the y value. So hopefully you indicate time as the independent, and then the height as being the dependent variable. So what we're looking for in terms of being as specific as possible, that with this graph here, that for every 12 hours, the graph is returning to the same height, as well as from here to here again, every 12 hours, it's returning to the same height, which is back to 0. So the graph itself is periodic, and the period is a 12-hour period of time. All right, so if you would go ahead and finish the remaining problems, this is kind of the closing activity. You'll see a lot of questions here that relate to things we've done in previous units. In Unit 5, there are only 3 lessons, so we should be able to finish up Unit 5 next week, and there'll be probably a short assessment of some with lesson Unit 5. The main idea here will be identifying graphs as periodic, and also more discussion on the tangent function. So it asks you in 15, 16 to describe what's happening. So I decided to go ahead and construct a graph. Basically, starting at P, the value of x is going to be 1, and as you go clockwise every 90 degrees, the value will be going from 1 to 0 to -1 to 0, up to +1, then back down to 0. So the highest the value is going to be is 1, the lowest value is going to be is -1, and it's going to repeat every 360 degrees, or every 2 pi. With the y value, you're going to begin at 0 at where P is currently, and then every 90 degrees from 0 to 1, back to 0 to -1, back up to 0, and then finish off at 1. And this again is also going to be a periodic, and the period is also every 360 degrees, or 2 pi, going from 0 to 0. Problem 17, they're asking you to put in tick marks. It's real similar to what I just demonstrated in the previous 2 problems. For cosine, that'd be an x value, and you're supposed to do the graph in radians. So your graph should look something like this, with respect to our unit circle. And then you need to if you're not connected the points, you need to connect the points. So the graph will look like this. So this represents 1 period, which is 2 pi. So it starts at 0 pi, ends at 2 pi. So this will be the repeating graph. So if I would start at 2 pi and go to 4 pi, the graph would be the same graph. So again, this is a periodic graph, and this represents the first period, which again is 2 pi, for cosine. It's a cosine graph. So cosine being the x values of our coordinate grid. And then in problem 18, they ask you to do the sine function. So this would be the y values. So again, like I showed in problem number, I think it was 16, base you're starting at 0 at 90 degrees, or pi over 2, you're at the height, which is 1. At pi, you're back to 0, and then again, it continues to -1, back up to 1, or sorry, back up to 0. So this would be the graph, and again, since you're doing the y graph values, this would be the sine function for the y values. And if I go from 2 pi to 4 pi, this would be also the graph. It would continue. So also the sine function is periodic. So this is the last problem for this lesson. So on our next class, I'll provide you the homework assignment. Your goal for the remainder of this class is to work on your Delta Math assignment. If you've not completed it, it is a little bit longer than it has been previously. Expect the Delta Math assignments to continue to be this length, or maybe even a little bit longer each week as we approach your final examination. Also, we are really going to be transitioning into from this unit and into Unit 6 next week, looking at trig functions, specifically sine, cosine, and a little bit of tangent graphically. And so some of the previous problems, I've been asking you to translate parabolas. So there's been a couple of activities like that in your homework assignments. And what we're going to be looking at as we work through Unit 5 and into Unit 6 is how do I slide a function left, right, or up and down? Or how does the a value, which makes the graph go up faster, for example, how does the a value affect a sine graph or a cosine or even a tangent graph? How does period work into the function itself? So if I write the equation, is there a place where this represents the period in that function? So that's where we're going over the next couple of classes. So just kind of be aware of that, and make sure you bring your computer, because some of the programs I'm going to be using to illustrate transformations of functions with sine, cosine, tangent are best illustrated using technology. If you have any questions on this lesson, please bring those questions with you in the next class.